Okay, this video is for geometry, section 10.1. As I said in the introduction, our chapter is on circles. Section 1 is a discussion of the little definitions of parts of a circle and figures relating to a circle that we will be encountering as we work our way through this chapter. So, first of all, the definition of a circle says a circle is the set of all points that are a given distance from a given point. That given point is called the center of the circle, and the distance from that center is called the radius. Now, you'll see in the picture that's on the screen there that I've identified some points and I've identified some different line segments in the first figure and then some lines in the second. We need to talk a little bit about those in terms of the definitions. So first of all, when you name a circle, you name it by its center. So in this example, I would call this circle C. And in terms of figures, sometimes they'll give you just a little circle with a dot in the middle, and they'll put a C outside. So that's how you'll see it labeled. Now, when you ask to name the center, again, you name it by its point. So the center of this particular circle is capital letter C. So circle C. When you name any of the other figures, the reason I've grouped them like this is because it is important to note that all of these are segments, not lines. So when I name them, I have to use the proper symbol with them. That will be a huge point to identifying some of these on your homework. So from center to circle, I could have BC is an example of a radius, but I also have AC or CD. And again, note the symbol, that straight little line segment above each. Okay, when you go pass through the center of a circle and go from circle to circle, you create a diameter. A diameter must contain the center of the circle, okay? And remember that because it contains two radii, then it is twice the measure of the radius. They'll ask you to do a little bit of that with that as well. So in this case, I have the diameter that I would call AD. And again, note the symbol, okay? In contrast to that, okay, we also have what's called a chord. A chord reaches from circle to circle, but does not have to pass through the center. It could. A diameter is an example of a chord, okay, but all chords are not diameters. Okay, so DF, so again, let's just say AD is a chord because it goes a segment that goes from circle to circle, but more importantly, DF is another chord. Okay, so again, note the symbols, that's important. All of these travel from circle to circle, okay? They are all segments, and we're going to contrast that by looking at lines here that continue infinitely. Okay, in the next figure you see circle P. In circle P, we have two lines that are passing through it. We have the line KL, we have the line MN. Notice that KL only touches the circle once. Line MN passes through the circle twice. Okay, that is the distinction between the two types of lines you see to the right. A secant line is a line that passes through the circle exactly 2 times. So we would say that MN is a secant. Note the symbol now has arrows. Okay, a tangent will only touch the circle once. Okay, so we have examples of both of those. Now, one part of the exercises that we're going to talk a lot about in just a little bit here is going to be, can you identify the different parts and figures around a circle, and can you symbolize those correctly? So these examples are going to be very important to some of the problems that you're going to be asked to do. The third figure talks about a couple theorems that relate. Notice that you have the tangent line RS, and you have what's called the point of tangency at S. Okay, when a tangent line connects to a radius, as it does there, even though my picture is off, the two will always be perpendicular. Always, 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 always. So we have the potential of forming we have a right angle, but connecting some of the other points. For example, if I connect R to T, notice that we've now formed a right triangle. And some of the things that we talked about in the right triangle chapter can be used to find a missing segment, and they will in some of the examples we'll be looking at. Okay, so when the two connect, a radius and a tangent, at the point of tangency, there will be a right angle formed. Okay, you'll see that in some exercises. Lastly, this will also be part of some of the exercises. Okay, notice that in this last figure, okay, I've given you a circle, and from that circle, I've drawn 2 tangent lines. These would extend infinitely in both these directions. Okay, there are 2 tangent lines. From X to Y, you have the segment XY that is a tangent segment, part of that tangent line. Down below, you have the tangent segment XZ. Okay, what the third and final theorem says is that from a point outside of a circle, the 2 tangent segments must be equal. So we will be given some problems here, but ultimately XY must be congruent to XZ. So they're going to give us some expressions, or we're going to set those things equal, and then we're going to solve. Okay, so we're going to have to do some work with the definitions. We're going to have to do a little work with setting up some segments and finding some equal values. But that's going to be the biggest part of this first lesson here, is just identifying some of those simple scenarios. Okay, so to keep these videos short, I'm going to stop here on this part of it. And on the next video, I'm going to go through the worksheet that's with you, that you've been given for homework, show you what's there, what problems you need to do, and then help you through some examples.